We're now on to 7.2, which is the multiplication, Abby, of monomials by polynomials. Specifically, for most of these questions, it's binomials, but I digress. We start at question 4, and it says, what multiplication statement is represented by each area model? So if we think about what this black rectangle's area is, it is going to be the product of 3x multiplied by 2x and a positive 4, or the binomial 2x plus 4. So that's the multiplication statement that's represented here. It doesn't say to answer it, but if you did answer it, the answer would be 6x squared plus 12x, but that's the multiplication statement. Here, we have 4x multiplied by 3k, or sorry, 4k multiplied by 3k multiplied by 3.6k, or 4k multiplied by 3k plus 3.6 is the multiplication statement for that. Don't need the answer, but if you did, it would be 12k squared plus 14.4k. And finally, the last one would be k multiplied by 3.2k multiplied by 5.1, or k multiplied by 3.2k plus 5.1. When we multiply it using distributive property, if we did answer it, it would be 3.2k squared plus 5.1k if you needed a solution. Question 6 says expand each expression using an area model. So here we're going to take a rectangle and we're going to divide it into two parts. Now, since we have a binomial here and a monomial here, this is going to represent the binomial and this is going to represent the monomial. So my width will be 4r and my length will be 3.2r, and this distance from here to here will be 1. Expand the expression. That's what it would look like. So inside here, we'd have 12.8r squared and 4r, or the solution to 3.2r plus 1 multiplied by 4r will equal 12.8r squared plus 4r if you wanted the solution. But this is really what the question was asking you. Can you draw that to show the solution? Your next one will be the same type of thing. Your binomial will be the length, so I'm going to put 3a here and 6 here, or positive 6 if you want to write the positive sign. And half of a. Now remember, there's 3 different ways you can write it. Half of a, or if you think about taking a, if you wanted to get half of it, you could write it like that, because that's half of a. All 3 of those are the same. It just happens to write the coefficient of half because it wants you to be able to combine them here in a second. So half a. And if you think about what this is going to do, inside here, you're really going to multiply 3 by a half by a by a. 3 times a half is going to be 1.5. A times a is a squared. And here you're going to multiply a half by 6 by a. A half times 6 is 3, and simply an a. So therefore your solution is 1.5a squared plus 3a, or if you wanted to, you could have 1.5 a squared if used as a decimal. Or if you want to get really funky, you could go, that's 1.5 times a, which if you multiply the coefficient by the variable, considering the variable to be over 1, this is also 1.5a, right? 3a over 2. Any of those work. Most of you probably did this one as your solution. Question 8 says, what multiplication is represented by the algebra tiles? We didn't have to do 8? Okay. So here we have the monomial, and the monomial is going to be 2x multiplied by the length, which is going to be 1, 2, 3x and a positive 1. That's what the multiplication statement is. And the solution is what the area is inside, which is 6x squared plus 2x. 1, 2, 3, 4, 5. 6x squared plus 2x. Question B, monomial, binomial. It's a negative x multiplied by a negative x minus 3. That's our width and our length. And when we expand it using distributive property, we would get our area, which is a positive x squared and a plus 3x. And finally, our C looks confusing, but it's not so bad. Our monomial is here, which is 3x, multiplied by our length, which is going to be a negative x plus 2. If we were to expand without modeling it, we would use distributive property, but it's already been done for us because the area is actually the answer. So the answer is negative 3x squared plus 6x. Question 9, continuing along, says what multiplication statement is shown by these algebra tiles? Again, my monomial is here and my binomial is here. My monomial is negative 3x multiplied by the length, which is 2x plus 2. If I was to expand using distributive property, I'd get the answer, but I don't have to because the area is here. The product is going to be negative 6x squared, which is what I would have got if I multiplied these together, and negative 6x, which is what I would have gotten if I multiplied those together. And that's my solution. Question B, my monomial is now here, which is a positive 3x, multiplied by the binomial, negative 2x minus 1. And the solution is the area, which is negative 6x squared minus 3x, which is what I would have gotten if I expanded using distributive property. And finally, C, monomial, binomial, width, length, doesn't matter. Negative x is my monomial, multiplied by x plus 4 as my binomial. Negative x squared is part of the area, minus 4x is the solution, or what I would have gotten if I expanded using distributive property. Question 10 says expand the expression using algebra tile, so we're going to use our algebra tile model. We have a binomial and a monomial. I'm going to start, I always like to start with the monomial, but you know what, it's reversed, so I'll just go x minus 1, minus 2, minus 3, minus 4, minus 5. There's my binomial. 3x, 1x, 2x, 3x is my width. Connect the dots. There's your area. Bring your line straight across to meet the other side. And there's your solution. These are positive x squareds because it's a positive times a positive. And those are all going to be negative x's because it's a negative times a positive. My solution is 3x squared minus 15x when I look inside the area. For my second one, 2x, I'm just going to do it here just because I can. 2x is my length or my width, doesn't matter. Negative 2x, 1, 2, and positive 3. Oh, those are negatives. Oopsie daisy. Oopsie daisy. Fill in your area. Bring your lines over. Those are all going to be positives because it's a positive 1 times a positive x. And my solution is negative 4x squared plus 6x. Negative 4x squared plus 6x. On to question 12. It says expand using distributive property. So now we're not actually modeling it, but we are going to solve with distributive property. I'll do the first one by showing my work, and then we'll just do the rest without having to do it. So if I multiply 2x by 3x, and I multiply 2x by negative 1, what that will look like if I use my monomial times monomial is 6x squared minus 2x. Okay, so this here on your test is the work you needed to show here. This is what you did when you expanded it. And then the solution would be the product of both of those monomials. As we get better at it, we don't need to really show that work. 3p times 2p is 6p squared. And 3p times 0.8 will be a negative 2.4p when I expand that with distributive property. Here, expanding with distributive, I'm going to show the work here. 0.5 m multiplied by 7 will be 0.5 times m times 7, or 0.5 times 7 times m. 0.5 is half. Times is also thought as the word of. So really half of 7 is 3.5 multiplied by m. It's just going to be 3.5 m. Now, do I do all that? No, because you're really good at it now. But you get 3.5 m minus 6m when you explained here. So half m times that is 6m squared, actually, because m times m is m squared. Here, if you want to multiply it, you can actually reverse your distributive property. I'm actually going to write the work down for this. So a negative r multiplied by half r. That coefficient is negative 1 times r times half times r. When I break down the two parts of the monomial. Negative 1 times a half is a negative half. R times r is r squared. So when I multiply that first term, negative r multiplied by half of r, I'm going to get a negative half r squared, negative half r squared. When I multiply the last one, negative r by negative 2, I'm going to get a positive 2r because a negative 1 coefficient times a negative 2 is a positive 2. And that's my solution. And finally, the last one, or second last one, sorry. Multiply those out, I get 16.4n minus 57.4 as just a standard coefficient. And finally, the last one, hey, we have a trinomial for the first time. 1, 2, 3 terms in this polynomial. 3x times x will be 3x squared. 3x times 2y is positive 6xy. And 3x times positive 4 is a positive 12x. So the solution to that monomial times a trinomial will be 3x squared plus 6xy plus 12x. Now we get into the nitty-gritty of our story problems. It says a rectangular quaqueult button blanket has a width of 3x and a length of 4x minus 3. What is the expanded expression for the area of the blanket? Again, length area equals length times width. Area equals length, we're going to make it 3x because I like my monomial first since it doesn't matter. And 4x minus 3 will be my other one. Expand it using distributive property. 12x squared. Negative 9x will be your area. And finally, B says, what is a simplified expression for the perimeter of a blanket? So since there's two formulas you can use. So the perimeter is really 2 lengths plus 2 widths, right? That's the formula we would use for the perimeter of a rectangle. So not using an algebraic one, let's just use a simple one. And we'll do 3 here. If I said, what is the perimeter of this rectangle? You would say, well, there's 2 lengths and there's 2 widths that make up the distance around the perimeter of the rectangle. 2 lengths and 2 widths. So the 2 lengths would be 2 tens because there's a 10 here and a 10 here. And there would be 2 widths or 2 threes because there'd be that and that. So when we think about the perimeter, it's going to be a 10 plus a 3 plus a 10 plus a 3, or 2 tens plus 2 threes, or 20 and 6. The perimeter of that simple rectangle in grade 4 or grade 5 would have been 26 units, meters, centimeters, whatever. Algebraically speaking, we can still do that same thing, except instead of having nice, neat whole numbers like 3 and 10, we're going to have, instead of having 10, we're going to have the expression 4x minus 3. Instead of being 3, we're going to have 3x, but the formula still holds true. We have 2 lengths, which is going to be 2 sides that are 4x minus 3. And we have 2 sides that are 3x. When I simplify this, I'm going to get, I'm going to get 8x minus 6, which again, if I'm thinking about the perimeter of this blanket, is this side and this side added together, 4x minus 3 plus 4x minus 3, or doubling 4x minus 3 will be 8x minus 6, and an extra 6x for this side plus this side. The full perimeter will be the addition of those. Gathering like terms is your chapter 5 concept. Remember what we did here? We actually kind of thought of it like this to help us see them all. I'm going to gather like terms. 8x plus 6x is going to be 14x. And then minus 6 is by itself because there's no other terms to gather with. And therefore, the simplified perimeter of that blanket will be 14x minus 6. Now, you could have also done this. You could have just said 4x minus 3 plus 3x plus 4x minus 3 plus 3x. That would have been the perimeter as well. But because we're using multiplication of a monomial by a polynomial, it's best to use the formula 2L plus 2W instead of side plus side plus side plus side. Question 15. We got just enough time, I think, to finish these up. Lee has decided to build a shed on a square concrete slab. The shed has the same width W as the slab. The length is 2 meters shorter than the width of the slab. What is an expression for the area of the shed? So we have W by 2. Okay, after a 5-minute pause, I've decided that this question is too wordy and I don't like it. So we're going on to this one. The basketball court for Jeux de la Francophonie is 5.5 meters longer than 1.5 times its width. Oh, this should be fun. So we're going to make the width W. And its length is going to be 5.5 meters longer than 1.5 times its width. So its length is going to be 1.5 times the width. But this distance is going to be 5.5 meters longer than 1.5 times. So we're going to add to this 5.5. So when we think about the expression that represents that basketball court, that is it. So if we fill in all the information, what is an expression for the area of the basketball court? It's going to be length times width. Or 1.5 W squared plus 5.5 W. That is the area, or length times width, of the basketball court. And then it says, if the length is 28 meters, what is the area of the basketball court? If the length is 28 meters. So therefore, this distance here is how long? How long is that length? 28 meters. So therefore, this expression is also equal to 28. You with me so far? This algebraic expression is also the length, which is 28. So therefore, we can make an equality or an algebraic equation that we can solve to figure out what the actual W term is. We're going to solve it by isolating the variable, getting rid of my constant first. Standard grade 7, grade 8 step is to get rid of your constant. I get 1.5 W equals 22.5. You with me so far? All I've done is I've gotten rid of the constant on both sides. My next step is to get rid of the coefficient, which is to divide both sides by 1.5. And I've isolated for W. Take my 22.5, divide it by 1.5, and therefore my W is 15. Is everybody okay so far? You with me? So I'm going to erase W now. And using a black marker, I'm going to put 15 meters there. You with me so far? And I can erase this, can't I? So how long is that? That's 28 meters, agreed? You with me so far? The question is, what is the area of the basketball court? I can now erase all of this. And the area of that basketball court is going to be length times width, or 28 times 15, or 280 plus 140, which is 420 square meters. I think, oh God, I better check that out. 28 times 15. Ah, phew. I can multiply in my head. Any questions? And our last question says a rectangular field is 4x plus 2 meters long. The width of the field is 2. Oh, drop my marker. 2 meters shorter than the length. So let's draw this again. The rectangular field is 4x plus 2 meters long. The width of the field is 2 meters shorter than the length. So it's going to be the length minus 2. Agreed? What is an expression for the area of the field? Well, really, if it's 2 meters shorter, that's the length. Therefore, 4x multiplied by 4x plus 2 would be the length and the width, or 16x squared plus 8x is the area of the field.